Today on the laboratory, we're going to try and change the light in this cat. It has an RGB LED in it that just rotates through all the colors. As you can see, it's slowly changing from teal to blue, and then it'll go from probably blue to green, or actually blue to white, then green and yellow. The person that uses this cat for display of their animal-related merchandise wants to know if I can make it just glow in the color of their business, which is teal. Teal LEDs really don't exist. How you get teal is you blend blue and green together and you get teal. Depending on how bright you make either one of those LEDs determines the intensity of the teal. If the LED for blue is brighter, it'll be more on the blue scale, more on the green scale if the green one's brighter. So we're going to see if we can take a couple of LEDs in here, point them at each other, or put them in a diffuser to make this glow in a shade of teal. So if you watch the video where the candy cart was made, the slideshow with some video in it, you would see this at the end in the still shots, sitting there on the cart. So that is today's project. See if we can open it up and make it change colors. Well, change color to a solid color. So I'll show you what we can do. Stay tuned. Alright, we're back with normal lights on, so you can see. There's really no access on the bottom as far as traditional. There's no screws. Batteries, it takes 3 AAAs. Those out. We'll try to. There we go. So, but right along the edge, this is a pliable plastic, kind of like a polyurethane or a rubberish. This is hard plastic, and looking at it, there's a small gap right in here, which I'm assuming is how they pressed this into, lack of a better term, the butt of the cat. So we're going to see if we can try and pry this guy back out. I'm expecting only to find on top of this battery pack, I'm expecting to find a resistor with just a standard color changing LED chip. I'm not planning on seeing anything more than that. I don't think it's high tech enough to have a circuit board. So I think it's only 2 components. If anybody's ever taken a tire off a rim, it's like the same process. Slowly work away around the edges. There we go. You can see, just a big hollow cat's butt. And, yep, switch, resistor, RGB light. Yeah, pretty basic. Truthfully, the way I would do it, if it was something I was contracted to make, that they wanted a color changing. What I do like about this color changing one is, as you saw, it's just a slow, continuous change. If you see a lot of these, they're rapid. They do slow transitions, and they go to a rapid flash, and then they go back to slow transitions. I actually like this one because it's just a slow transition. Also, most of those rapid change or variable speed ones, they're clear. If you look at this LED, it's frosted. Frosted LEDs disperse the light a little bit better. You get less of the pinpoint coming off the end. So what we need to do is start testing out some blues and some greens, whether they're clear or colored plastic, and see if we blend them together, which one gives us the best teal. I'm sure I only need one of each with a diffuser, since as you saw just one LED in here, the whole cat lit up. It was a little brighter in the torso and not as bright in the head, but when you're shining a light straight in, it's tapered. So you're going to have more light here, less light here. Unless you decide to stick the light way down in there. Yeah, that was kind of inappropriate, but it is what it is. And yeah, this inner lip is a really soft, pliable rubber. So basically it's a press fit, and there's a groove right on the inside. So, not very expensive to make. Probably made in China. But, so, nice little cat. Yeah, there's no markings. All it says is off on. So, I'm going to find some LEDs and some testers and kill the lights again, so we can shine the lights onto the surface. I'll get a white piece of paper or something light so we get a more accurate look at what the teal would look like. So let me grab some lights and we'll be back. Alright, we're back. Easiest way to do it is to show you. I have a green LED on this tester and a blue LED in this one. If I put them side by side, the green works, the blue doesn't, because as you can see, there's multiple rows. The green is less power draw, least path of resistance. All the power will take the least path of resistance. So we put the green light in here, and then put a little blue in there. We now have teal. It may not show up so well on the camera. That's the problem with light sometimes. But it's actually teal in color because the two lights are in there together. And depending on how you look at it, you will see splotches of green and blue because, well, it's a green LED and a blue LED. It's interesting. The red shows up from the light right there. Anyway, the problem is again, they're two different resistances, so to make them work off the 4.5 volts of power that come in from this battery pack, we're going to have two resistors, one for the blue, one for the green, because they draw different amperages. So I have to get the calculations figured out for the resistors, and then we'll just solder them on and we'll have a teal cat, which actually, just like this, where they're side by side, doesn't look bad. So instead of trying to blend them with a diffuser, since the cat is opaque, thinking just leaving it like this, where it's teal and you get a couple of rings of green and blue mixed throughout, it actually looks really good to me. And the head doesn't look too bad either. It's got a hot spot, but it's not horrible. So get some lights on, do some calculations. You just have to use Ohm's law. If you don't know what that is, it's something you can look up online. There's calculators online that will tell you how to do it. There's it's a pie chart. When I grew up, it was when I did electronics, it was just a standard little chart, a little circle. We used to get little business cards with them that had the different ways to calculate your power, your resistance, your amperage, and your wattage. So if I find one, I'll show it to you. But I'm going to go get some lights on and get some resistors. So I'll be back again in just a moment. I couldn't find mine, but here's one online, so you can figure out your power. So here's your amps, your volts, your power, your ohms. We need to figure out ohms for this right here, for these two LEDs. So you need to know your power, your amps, you get your resistance. We know the power is 4.5 volts. And then the amperage squared is right there. And I'll keep moving off camera, sorry. The amperage on these is approximately 20 milliamps, 15 to 20. So it'd be power over 30 to 40 milliamps, and that would give you a resistance. So, but that's the little chart that I was talking about. I used to have a little color wheel like this that they gave us that you could spin the wheel to help line up the different equations. So if you're ever curious, you can also just type in Ohm's law calculator or resistor calculator, and it'll tell you the same thing if you want to Google it. So, but since I could not find it, I figured I would just show you what it looks like online. Like I said, I have a little business card with it, as well as an actual spinning wheel, which, of course, when you want to show something, you can't find it. But anyhow, let me get some resistors, and we'll be right back. All right, we're back. Got some resistors for the green light. We need 100 ohm, which I have some. For the blue light, we need 75 ohm. I don't have any 75 ohm resistors, but if you take 250s and put them in parallel, make 75. So that's what we're going to do. So we are going to solder 2 resistors parallel to this one resistor to that one, then to the switch and the battery pack like they have here. So I'm going to desolder this, and off the switch, and we're going to replace them with some new parts. So, we can see here, their leads are slightly longer than mine. So, I'm going to want mine close to this center section, and I'm going to common the hots, and then put the resistors on the negative sides. So, I guess I should get some solder out. On an LED, if you're not familiar, the hots are the longer lead, or the positives. So, there we go. And we're going to take a small piece of wire, and we're going to solder it so I can try and get these as close to the center as possible, since I have shorter leads on my 2 LEDs. So I'm going to put the LEDs right near the center, where there's a stand, where the original one should have been. So they'll sit like that. And you can tell I'm just a hair too short from getting to that positive plate right there. So instead of using long piece of wire. I'm gonna strip off some of the insulation. Cut the wire, and we're gonna solder it on. So, I'm gonna try and bend the wire just a little bit. I'm trying to have these centered as close as possible. There you go. Now, since they both are clear, and I didn't mark them, I'm going to quickly test to see which one's which color. So I have my power supply on at a little over 2 volts, and that one's green. It's set at 2.2 volts. Green turns on, but the blue doesn't. The blue won't turn on until it hits over 3. That's 3 volts. That's why we need to have 2 different resistors. It's because the power consumption is different. So. We're going to solder to the negative, and then we're going to solder off the switch, and I'm going to run 2 wires off the switch, just more of the little solid core wire here. And for paralleling, parallels where they're side by side, this would be series where they're end to end. So to reduce space, I offset them by the width of the resistor and then twist them. And then I hit them with solder. This will give me my 75 ohms, and it takes up less space. Now they're more permanently together. Alright, to ensure that the metal contacts don't bypass the resistor and then overload the LED, I'm going to insulate one set of resistors with some heat shrink. Too long. Alright, we're going to change this up a hair. There you go. I was thinking about it. It'd be easier just to run the switch the other direction. That's how it works. You do things, you realize you might have an issue, and then you fix it. Nobody's perfect. Let's get a little bit better solder on this. We'll get some hot glue. We'll glue this on. kind of put one on either side here just to hold it out of my way. And then we'll test it before we actually glue them in place. Now it's a lot of white background, so I'm hoping that it's picking everything up on the camera. Now on the switch, there's an actual hole that they fed the original wire through. I'm going to see if I can do the same. Well, I did it. Just had to clean some of the solder out that they put in there that was left. And ooh, that's hot. All right. Cut off the little piece sticking out so it sure doesn't touch the other wire when I solder it on. Remove the point. So now we just need to make a wire from this side of the switch to there. So again, I'll use this same piece of green. Let's just see about here. I normally don't use solid core wire on stuff because it's brittle, but on small projects like this where there's going to be little motion to the actual component, it's not too bad. Solid core wire, if you flex it too much, has a tendency of breaking. A lot faster than the stranded cores. Small projects I'll use solid core like this, but when I do my big projects like when we build custom cars, it's copper and it's stranded to handle the power consumption of usually the components that we're putting in. Also, when I do the Limax repairs or animated houses, I try to use small stranded. I try to stay away from the solid core because if the animatronics are moving the stuff around, or if you're moving your houses from display to storage, all that jostling will cause the strands to break. And if you're new and you're wondering what I'm doing off camera with the soldering iron is I'm cleaning the tip. The solder I'm using is a lead based and the tip gets gunky pretty quick. It's also an older tip. It's probably time to replace it soon. Alright. Cut off the extra long piece and let's see if it works or if I wasn't paying attention and I reversed something. Here we go. Alright, so with them separated, there's a very obvious demarcation point in the light. So let's do some adjustments in the dark. Let's kill some lights and see what happens. Alright. It's really hard to tell on camera again. least it is in the little viewfinder. But it is teal, except for the ears. One ear is green, one ear is blue. And you got the line, which I said you would have from the resistors. Sorry, the LEDs. I can crack them. Cracking them is the term where you take a pair of pliers or cutters. I'm trying to do this without swapping out the camera too much. And you break the ends of the plastic off. It creates, instead of getting a beam, you get more of a diffused pattern. I try some more bending and see if we can make it look a little better here. What I'm doing is I'm rotating the base to see if I get a better view. Alright. Why don't we try the cracking technique. I use a pair of wire strippers and I'm just going to crack the top off. The reason I use the wire strippers is with the curved teeth for stripping wire, I get a better grip. You can use wire cutters, anything that has a point that'll start to crack the plastic. So you want to be careful, because if you crack too far, you'll expose the chip on the inside and your LED is useless. They do make LEDs that are pre-cracked, I guess you would say. You can get those. And that helps diffuse the light. No more beams anymore. If you notice the hot spots, if you saw it just a moment ago, there are no more hot spots. So there we go. Just got to pry this bad boy back in. What you saw is the same as taking it out. Start on one edge and then slowly work your way around it. And now she has a teal cat, which again I hope shows up on camera, because on the viewfinder kind of looks purple with a white body. But it's actually teal. So that's what it takes to convert something when they don't make a color LED for it. I am going to glue the lights down. I'm going to put a dab of hot glue between them. Just so when it's in transit and storage and it gets dropped or jostled, I don't have to worry about the wires being moved around or the LEDs coming out of their positions. So other than that, hope you enjoyed it. Hope you learned something. If not, sorry. But there we go. A nice teal cat for a display for an animal bow and handkerchief manufacturer here in Arizona. Thanks for watching. Until next time, enjoy.